Imagine a processor running nearly every smartphone, cloud server, and modern gadget, yet it originated with a tiny, frantic British startup operating out of a literal turkey barn in Cambridge. It sounds like absolute madness, but the most pervasive computing brain in modern history was born entirely by accident, created by brilliant amateurs who thought building processors was utterly terrifying. To understand this wild technological dominance, we must rewind back to the 1980s. The British tech scene was basically just two eccentric men aggressively trying to build cheapest computers. Acorn Computers and Sinclair were locked in bitter combat. Acorn desperately needed to win a juicy government contract to build the official microcomputer, but they lacked an actual physical product. Their boss casually promised a fully working prototype by Friday. Sophie Wilson and Steve Furber miraculously pulled an absolute all-nighter marathon to build this legendary machine from literal engineering scratch. The machine successfully conquered British classrooms, making the company immensely wealthy. But as Acorn dreamed of building advanced workstation computers, they discovered complex 16-bit microprocessors were hopelessly bloated, terrible silicon nightmares. Instead of surrendering, Wilson and Furber visited an American design lab, discovering it was just a suburban bungalow using high school students. Suddenly, designing a new chip felt comically highly achievable. They stumbled upon obscure academic papers detailing reduced instruction set computing. The radical theory proposed abandoning complex processor instructions to build something stunningly simple, ridiculously fast, and shockingly cost-effectively efficient. The Acorn RISC Machine, or ARM, was secretly born. Sophie Wilson drafted a beautifully elegant instruction set, whilst Steve Furber painstakingly translated her brilliant logic into actual physical silicon processing circuits. They faced one incredibly draconian requirement: the chip absolutely had to fit inside a shockingly cheap plastic package. This mandated that the processor must produce virtually 0 watts of thermal heat. When the first silicon samples finally arrived in spring 1985, the engineers plugged it in. The screen boldly flashed "Hello World," completely shocking the entire hopelessly tense engineering development team. Then, something truly bizarre happened. Furber measured the power consumption and found it drawing 0 watts. The chip wasn't technically plugged into actual power, it was running perfectly on leaked current. This accidental, freakish power efficiency was a beautiful miracle. However, despite this world-changing processor sitting right in their labs, Acorn Computers began rapidly imploding due to completely terrible market product choices. Warehouses sat overflowing with unsold computers, practically pushing Acorn into bankruptcy. Italian firm Olivetti essentially acquired them on life support, totally baffled by chaotic British corporate strategies unfolding remarkably chaotically daily. Realizing their miraculous processor architecture would instantly die inside a failing computer brand, they desperately needed to spin ARM off into its very own independent, Fabless Semiconductor Holding Technology corporate company. They desperately pitched the technology to everyone across the tech industry for 3 agonizing years. Nobody believed a tiny, random British team could revolutionize global microprocessor architectures against huge American giants. Salvation magically arrived from Apple Computers. They were aggressively developing a revolutionary handheld digital assistant called the Newton, which desperately required immense processing power combined with extremely long battery hardware life. Apple was initially using a spectacularly terrible processing chip named the Hobbit. Frustrated engineers luckily discovered the incredible ARM chip hiding secretly as a peripheral controller on their testing hardware boards. Testing proved the ARM architecture was absolutely flawless. Apple immediately injected millions to co-found Advanced RISC Machines, officially setting the stage for an unprecedented global microprocessor revolution. A perfectly ideal partnership. To lead this daring new venture, they hired Robin Saxby, a remarkably charismatic technology salesman who previously managed to accidentally tackle the Acorn founder while skiing clumsily in the snowy Alps. Saxby had a completely insane vision. Instead of spending billions constructing expensive physical manufacturing factories, ARM would operate completely fabless. They would exclusively strictly design and license purely intellectual property blueprints. This strategic business model was dangerously unheard of back then. Saxby fiercely recognized they absolutely could not fight Intel on desktop computers, so they ruthlessly pivoted toward embedded mobile system standards. Their core philosophy was shockingly simple: explicitly sell the highest computing power per dollar and the most processing capability per single electrical watt. The embedded mobile industry ultimately could not resist. While the Apple Newton notoriously tanked commercially, Nokia emerged desperately needing a hyper-efficient processor for their business-targeted GSM cell phones. They demanded massive battery life for busy touring corporate executives. To cleverly win massive Nokia contracts, ARM brilliantly developed the thumb instruction set, forcefully squishing 32-bit processor performance down perfectly into a tiny, highly constrained 16-bit memory software envelope. This ridiculous feat created the iconic Nokia 6110, establishing ARM globally as the undisputed reigning monarch of low-power portable mobile devices. Suddenly, the Japanese tech giants came aggressively actively knocking. Sharp and Nintendo utilized this exact tiny, incredibly efficient processor architecture to exclusively power their universally legendary Game Boy Advance handheld console. The fabless intellectual property licensing strategy essentially printed literal money. As the smartphone revolution dramatically exploded in the late 2000s, practically every single touchscreen mobile device fundamentally required ARM's insanely optimized, perfectly engineered, spectacularly reliable, battery-sipping miniature processing architectural brains. But why could not Intel compete here? Technically speaking, older architectures like Legacy x86 severely suffered from horribly complex variable length instructions, making parallel decoding absurdly expensive regarding pure electrical operating energy. Intel processors literally must guess where complex instructions explicitly terminate. This mandates heavily intensive silicon logic just to randomly parse operational inputs, burning incredibly massive amounts of extremely precious laptop battery life. Conversely, modern ARM instruction lengths remain elegantly fixed and stunningly predictable. Processing decoders easily parse multiple commands instantaneously in perfect parallel harmony, demanding phenomenally lower silicon physical space and overall electrical wattage. For decades, Intel completely dominated desktop markets while aggressively ignoring baseline energy efficiency. Meanwhile, ARM stealthily conquered millions of low-power mobile platforms, progressively quietly improving overall computational processor capabilities absolutely yearly. This dramatic fundamental difference perfectly positioned ARM to ruthlessly execute the ultimate technology hardware heist. Slowly, they transcended cheap portable toys, violently knocking upon Intel's highly lucrative high-performance computational desktop kingdom. Apple suddenly dropping Intel processors completely shocked the global industry. They daringly replaced aging desktop chips with incredibly customized ARM silicon, delivering phenomenally staggering speed boasting 22 entire hours of continuous battery. It was an absolutely massive humiliation for traditional computing design paradigms. The fabless licensing model allowed Apple to perfectly tightly integrate customized microarchitecture alongside ARM's incredibly brilliantly optimized basic processing instruction set. And the spectacular silicon hardware invasion did not magically stop there. Giant server farms demanded massive cooling power, rendering old x86 platforms ridiculously expensive liabilities inside massively sprawling modern cloud networking infrastructures. Amazon aggressively recognized this extreme computing weakness early, secretly developing custom ARM Graviton server processors. Suddenly, Fortnite game servers operated far cheaper, running remarkably cooler across massively highly scaled global AWS data centers. Google promptly copied this genius fabless masterpiece formula. Their insanely efficient Axion chips immediately boosted performance metrics while heavily slashing brutal energy requirements across giant global YouTube advertisements serving network hardware deployments. Microsoft Azure obviously followed suit, deploying massive custom Cobalt processor clusters. ARM architecture officially conquered the hallowed data center, brutally displacing Intel's ancient legacy monopoly utilizing vastly superior holistic hardware power conservation designs. Even reigning artificial intelligence hardware king Nvidia heavily realized ARM's majestic potential, intimately pairing powerful Grace architecture processors alongside huge Blackwell graphical computing units to exclusively power sprawling generative AI computational factories. Nvidia practically tried aggressively purchasing the entire ARM company for $40 billion. An absolutely furious global consortium of deeply terrified tech competitors completely panicked, actively forcing federal government regulators to intervene. Following that dramatic failed total acquisition, ARM majestically dominated the global stock market. Their massively lucrative blockbuster public offering completely re-established overwhelming global confidence regarding their brilliant fabless chip IP designing methodology. Their stunning intellectual property licensing model is completely unassailable and unparalleled, collecting extremely lucrative royalties from basically almost every single electronic device manufactured globally is obviously an insanely brilliant recurring financial masterstroke. Modern electric automobiles are fundamentally becoming heavily sophisticated computational platforms. Autonomous driving networks aggressively require intensely optimized, highly robust processing cores perfectly provided seamlessly by ARM's wonderfully powerful Neoverse unified architectural standard. Naturally, fierce industry competition constantly evolves relentlessly forever. An open-source rival architecture named RISC-V is rapidly gaining considerable momentum amongst global embedded devices, fiercely promising perfectly efficient processing without royalties. Yet ARM maintains an incredibly colossal strategic business advantage. Their gigantic global ecosystem practically guarantees universal established software compatibility, something that newer open-source rivals unfortunately absolutely require grueling decades functionally replicating. Qualcomm is currently aggressively battling ARM through highly complicated legal court litigations over disputed licensing terms, ironically highlighting how heavily dependent major tech giants remain upon this incredibly pervasive British processor architecture. Even amidst deeply concerning geopolitical trade tensions heavily impacting vital Chinese market revenues, ARM continuously systematically reports increasingly higher royalty percentages reliably harvested efficiently from practically every single globally manufactured modern smartphone. The massive artificial intelligence hardware boom gripping Silicon Valley practically guarantees that ARM's underlying structural technology will forever remain incredibly critically necessary for effectively powering highly complex future continuous computational systemic algorithms. From tiny embedded household sensors reliably monitoring ambient temperature fluctuations directly to massive hyperscale cloud environments, this fabless architectural masterpiece flawlessly demonstrates how extremely focused brilliant simplicity effectively consistently conquers systemic complexity. Let us seriously reconsider that completely insane total global shipment volume. More than 250 billion brilliant ARM processing brains have successfully deployed globally, literally substantially outnumbering the entire human population. 30 billion perfectly optimized hardware processors currently formally ship annually. That staggering unprecedented proliferation perfectly illustrates how purely licensing brilliant intellectual property elegantly effortlessly sidesteps crippling physical global chip manufacturing plant limitations. Intel dangerously stubbornly clung toward aggressively rigidly controlling their physical semiconductor fabrications. Meanwhile, incredibly nimble fabless designers simply outsourced brilliant ARM blueprints toward massively scaled external global manufacturing corporate silicon titans completely. This flawlessly brilliantly separated hardware manufacturing from purely imaginative architectural ideation. Consequently, hyper-focused cognitive engineering essentially generated astronomical market valuations completely entirely devoid of physically producing literal raw silicon hardware whatsoever. Some overly cynical tech historians falsely continually assume ARM utilizes drastically simpler reduced instructions. Reality completely beautifully contradicts this overly romanticized myth. Modern ARM implementations boldly employ hundreds of highly complicated instructions. Underneath the microscopic hood, modern ARM processors heavily utilize extremely sophisticated microcode structural layers. They flawlessly perfectly translate complicated incoming commands into tightly optimized parallel operations smoothly executing across advanced hardware matrices. However, their famously open licensing paradigm heavily actively encouraged wildly diverse global engineering teams to creatively aggressively experiment, collectively pushing wonderfully efficient foundational architecture toward absolutely magnificent entirely unforeseen hardware processing limits. If ancient x86 computing technology possessed similarly wonderfully open intellectual property licensing structures, perhaps alternative competing independent engineers could identically optimize it toward equally stunningly incredible extreme low battery consumption electrical metrics. Instead, ARM gracefully monopolized that intensely vital global mobility sector completely flawlessly. We literally smoothly run highly complex virtual computational existences upon invisible structural foundations originally designed inside an obscure Cambridge barn. This gloriously weird British technological phenomenon fundamentally flawlessly reshaped our entire modern digital reality. The fabless semiconductor miracle effortlessly completely conquered Silicon Valley utilizing pure genius, relentless physical efficiency, and absolute audacity.
If you find this video interesting, push like and subscribe buttons. Take care.